thank you for the nice introduction. And thank you for having me. So let's dive into the topic about Azure Functions, so about a very specific area of the Microsoft offering. Within the next, well, I think 45 minutes or so, I will shortly talk about why I think we are doing serverless and what's the reason behind doing that. Then I will go to Azure Functions and shortly show you how do they work, what can you do with them. And then I will dive a bit deeper and talk a bit about what happens if this cool stuff like functions meet reality, namely something like business processes, and what are the challenges that arise then. And the answer to that challenge will be Azure Durable Functions, where I will spend quite some time during this talk. Yeah, before we start, I mean, there was already an introduction. I'm around software development now since about approximately 15 years. I have an SAP background, but don't be afraid, don't leave the meeting. I will not talk about ABAP in this talk. I have some focus topics due to that background, so it's mostly about extending existing functionality, extending systems. And well, I've focused since the last years on cloud native development and serverless, especially with focus on the Microsoft offering. And if you want to reach out to me, easiest ways we are Twitter or via LinkedIn, whatever you prefer. Okay, so one very short slide about the motivation. Why should we think about serverless? Why should we take a closer look at the serverless offerings of cloud vendors, and especially into functions? So basically that's the motivation, the basis, the baseline for using the cloud. So what we did, or what was the intention to use the cloud? It was to abstract the stack away that we had to use in order to build solutions and focus more and more on business logic. And well, the story started, I think, with virtual machines that every cloud vendor has, where we abstracted away a bit of the stack, but had already a lot to do with infrastructure in order to make things running, and could not really focus on business logic. Next step then was containers. I think there are different levels of abstraction within the container area. So I think Cloud Foundry is something that is a quite high level of abstraction, where you just put in the code into the Cloud Foundry environment and let it run. You do not care how, at least that's the theory. Or you have the famous Kubernetes offering, which from my perspective is a little bit more a lower level of abstraction, so less focus on business logic. And last but not least, that's why you're probably here and what you already heard in Ottmar's talk, I guess. At the end of the current stages is serverless, which is an extremely high abstraction of the stack, which also means you might lose some flexibility, and a very, very high focus on the business logic that you can implement. So when we talk about serverless, we talk about fully managed services with a very flexible scaling. So we have make use of the cloud qualities to a quite high degree. What is very nice is you only pay for what you use, and something like functions will scale down to 0. So if you do not call your function, you will not pay for anything. You usually have a quite seamless integration, and you will see that also with Azure Functions into the ecosystem of the vendor. And at least that's the idea, you have an enhanced productivity, which you probably will also see when it comes to the tooling. Now, before I go on, I would like to have some input from your side concerning functions as a service. So purely functions as a service. Which offerings do you know or do you use, just to get an impression? What's your background? So you can go to menti.com, enter this code. You can also do that via mobile. And then let's see where we are. What's the best known stuff? Oh, I think that was the wrong number, right? Sorry for that. This would be the right one, 463753. So just grab your phone and go to menti.com. No surprise. Ooh. Okay, nine folks have voted. So we are now, I think 16 or something like that, right? So either you are afraid to vote or you have not yet used something like functions as a service. But this is something that, yeah, looks quite familiar. So I think the AWS offering with Lambda is quite well known. Google usually is not that well known, but yeah, surprised in that area. And Azure Functions is not known. That's how it is. Now we want to put some light in here concerning the function as a service offering from Microsoft. So what does Microsoft bring to the table? And the answer is simple, and this is also the title of the talk. It's about Azure Functions. Azure Functions have this nice lightning in these brackets as a symbol. And those are the things, or those are the offerings that Microsoft has when you speak about functions as a service. Now, how does this look like concerning the Azure experience? So I will now shortly switch to the Azure portal. So for those of you who do not know Azure as an offering, so you have, as for AWS, something like a portal. This portal follows some kind of user philosophy. So you have those blades at the left-hand side, and then you have the detailed information on the right-hand side. And if you dig deeper into the details, more blades will open up. So you get some kind of stack. They will be hidden then for usability reasons, and that's what you see. And now for functions at Azure, you have some kind of a container that's called an app service, where you can deploy several functions into. Here you have the functions, and all these functions then share one global configuration. Each function can have, in addition to that, some local configuration that's then specific to the function, but you can also drag out some stuff there. You can put some settings concerning authentication, authorization. We have monitoring of the function. That's offering is called Application Insights. And well, you have a lot of other things that you can do in order to implement the functions, to develop the functions within Azure, and in order to monitor them, to configure them, and so on and so forth. But from my experience, well, nobody develops functions in a web interface, in a web IDE. At least I did not come across a lot of people who like that. So that's why also Microsoft decided to allow a developer to make the development purely local. And it's very, very easy to do that. So what you have to do basically is to install the so-called Azure Function Core tools. These tools, as you can see here, I will make it a bit bigger, is simply an npm install of the Azure Function Core. So what you need is a Node.js environment on your system, a long-term support environment. So currently Node.js version 12. And then you do the npm install, and then you are good to go to develop Azure Functions locally. I have all that stuff on my system, and I would like to show you how easy it is to make your first touch points with Azure Functions. So the first thing that you should do is install one extensions in Visual Studio Code. I think that's a quite common IDE that you can use. And there you have an extension that you can install from the marketplace that gives you a bit more guidance when you want to develop a function. You can also do that from the command line. So the function core tools come with an CLI, but that's a little bit more clumsy. You need a bit more experience to get things started. So I would recommend install Visual Studio Code. I guess everybody has installed that stuff. Then go to the marketplace, install the extension, and then you get this little thingy here that will help you to create your Azure functions. Now, as you can see here, I will make it a bit bigger. Please just shout into the session if the screen is too small. I'm not signed into Azure, so it's completely detached from Azure, and I will now create an Azure function and will execute it locally. So what I first have to do is I have to kind of mimic this function app, this container, by creating a new project. I will use a local directory for that. And then in the next step, you see which languages are supported out of the box by Azure Functions. So for sure, you have C#. We are in the Microsoft ecosystem, so C# is the first class citizen. You have Java, you have Python, you have JavaScript and TypeScript. And last but not least, you have PowerShell. So those of you who are around ops, that's an interesting thing to look into in order to automate stuff. So we will now go down the TypeScript path. And in the next step, you have to define how the function gets invoked. The most prominent thing, that's basically the HTTP trigger. So you make an HTTP request to the function, you kick off the function and do your thing. There are also some further triggers available for Azure Functions, which are mostly coupled to offerings on Azure, like the blob storage, the Cosmos DB, which is kind of the DynamoDB in Azure, Event Hub, Grid, and so on and so forth. I will talk later about durable functions. That's what you can use. I will now go for the HTTP trigger. Then you have some authorization level. Don't do that in the wild. Going for anonymous. And what happens now is the extension together with the core tools does some scaffolding. So it creates you all the infrastructure, all the settings that you need in order to develop your first function. So what you have to do now is to do an npm install to get the dependencies right. Yeah, so that's it. So let's take a look what was created. There is some stuff around like function ignore, like git ignore, so you can directly push it to git and not do not push stuff like the node modules folder or something like that. You have a package.json as usual, with some nice scripts that you can use. You have some dependencies, and you have something that's called a host.json file. That's the global configuration. So that's the configuration on the app settings level that is relevant for all the functions within your project. There is some defaulting concerning application insights so that you do not overwhelm the monitoring with unneeded data. And there is another thing that I will talk about later. And the core of everything is then this little folder that's called HTTP trigger. That's the name that we gave our function. And every function within Azure, and I think that's quite common to other areas, consists of two parts. You have one part for the configuration, which is this function.json file, and you have the code that contains the logic of the function. So let's take a little look into this one. What we have here now is the kind of configuration for your function and also kind of information about your function for the function runtime on Azure or locally. So what we have here is all the stuff that we entered before. So this authorization level, we have the type of the trigger, which is direction inwards. So we say when an HTTP trigger comes in, this function gets triggered. How is this inward trigger called, or how is the data represented within the function via a parameter called REQ, request. Here we can define which HTTP verbs or methods are supported, and so on and so forth. What's important now, and what you can already see here, is with these bindings, you can glue up your functions with different stuff within Azure. So here we have a quite basic binding. We have an inward binding, which binds the function to the incoming request. And we have an outwards binding. So we return a result, which is given here. You can also, or the same mechanism is used in order to hook up a Cosmos DB, in order to hook up an event grid. So you do not have to care about how to address a database like a Cosmos DB. You do not have to care about how to address an event hub or something like that. The functions infrastructure will wire up everything according to the configuration that you have here. Concerning the credentials, you have to store them somewhere within the app settings. But you do not have to do anything within your code in order to hook up to a database. That's, from my perspective, a very, very powerful mechanism. Now let's take a look at the code of your function. It's really easy. You have an asynchronous function, which gets in a context, and the request, the parameter. And well, this is now really, really simple. We say, hello to League of Geeks. If we get a request query parameter name or something like that in the body of your request, and if not, we return status 400. So now let's kick up the function locally. So we will now start the function runtime within the directory of our function. Now we have some beautiful ASCII art that you saw. And this will now spin up the Azure Function Runtime. As you can see here, it picks up the configuration. And then it says an error, which is not good. Do we have something running somewhere? Usually not. That's live. That's how I like it. What I'll do now is put this extension bundle because it's definitely not needed. Let's keep our fingers crossed. Yeah. Okay. So now the function is up and running, and we have some local endpoint exposed that we can use now in order to call the function. I will do that now. I have a little Postman open, larger. So if I now call the function without a parameter, I will get the HTTP 400. If I now enter name, hopefully we'll get the right request. And that's all happening locally. And the same would happen within within Azure. As you can see here, you also get some logging information in your console. This is also something that would be logged within Azure. So no need to buy into Azure in order to make your first steps with Azure Function. Azure, yeah. So I think there are quite some common ways how to pronounce it, but let's stick to Azure. Okay. So that's it about the local execution. Now, as I said before, that's quite easy. That's not really real life, what you deal with in real life. So how do you deal with business processes and functions as a service? There are some principles that come along with functions that will give you some challenges when you deal with business processes. So first of all, in general, functions are stateless. So you cannot really store state within functions. Then another point is, as soon as you enter the area of business functions or business processes, you will have some sequences. You will try to put your logic into different bits and pieces, and which ends up into different functions. And usually you should not call other functions from within a function, because this gives you some dependencies that you usually do not want to deal with. And what's also best practice is functions should do only one thing, and they should do that one thing very well. As I said, functions do not have state, but business processes usually need state. And what you then usually do is you come up with something like this. You have a chaining of functions in order to achieve the state. So you start the first function, which does its thing. Then this function will store something within a database, or will store something within a database and raise an event. Then, due to this event, a second function will start, which will do its thing, and so on and so forth, depending on how you model your business process. Now, if you think about the diagram where we started from, we wanted to focus on business logic when we go for serverless, especially when we go for functions. And here we have to think about all the infrastructure stuff, right? So we have to put in queues, which are quite a kind of a necessary evil. If we want to have a context, we must store it in a database. So we have to do all the database handling. We have some quite loose coupling, which is in general good, but the relation between the functions within this sequence are quite unclear. And for sure, when you have such a sequence, the error handling becomes very, very complex. So there are a lot of problems or challenges that you have to tackle with when you want to process business processes in a purely serverless fashion. So this is where an extension of Azure Function kicks in as a purely code-based alternative. The durable functions. The durable functions are a true extension to the Azure Functions framework. So we have the functions framework as a baseline, and on top we have the durable functions. And the durable functions basically do one thing, and that is preserve a local state via event sourcing. And that's all happening behind the scenes. So all the heavy work that comes along with that concept happens behind the curtain. So you do not have to care about that, which allows you to focus more on the business logic again. And the durable functions framework also supports you with some further stuff that you need, like timers that we will see, like retries that you can use in order to deal with some business requirements. So how does this work? How does the durable functions framework help you? So let's say we have a situation as depicted before. So we have 3 activities or 3 functions that we want to call. And we have a sequence. So we have several tasks. The first task is executed, returns a value. And this value is given to the second activity. This returns a value, and this is then handed over to the third activity. This now looks like the following. So we have one function which acts as a trigger like we saw before. So this is kind of the entry point where your request comes in. and which triggers or starts all the consequent actions. Then you have one orchestrator function. This is, like the name says, orchestrating the sequence that we want to execute. And we have the activities, which are these Fs, F1, F2, F3, that do that job. So if we do a little walkthrough on the slides through this scenario, so what happens is a trigger gets invoked, and this trigger stores some information in an event queue that you do not have to care about, which tells the orchestrator, hey, I have something to do. After that, the trigger function scales down to 0, and the orchestrator starts. The orchestrator then picks up that message, takes a look at what do I have to do, and kicks off the first function with the information that it should hand over. Then the orchestrator scales down to 0, the activity starts, scales up, picks up the information, executes, does its thing, and returns the result, in this case, the X value. When the first step is executed, the activity scales down to 0, the orchestrator is getting up again, takes a look, do I have to do something more? Yes, there is a second function that I have to invoke. It invokes the second function, and so on and so forth. And all this happens kind of behind the scenes. You just have to implement the 3 functions, and all the hard stuff, all the wiring up, all the event handling is done by the durable functions framework. So in one picture, durable functions are something like that. So there is one orchestrator that kind of triggers all the activities, and the activities do the hard work. Now, what do we have to do in order to implement that in a local environment? So we already have the function core installed. Now you have to also install durable functions, so the extension. Then you also, if you want to develop locally, have to install the Azure Storage Emulator. The storage emulator, well, is there in order to store the state that is handled with the durable functions. Within the deployment in the cloud, you have a storage account connected to your functions, which is used in order to store that. When you do the development locally, you have something that emulates that. And that's the Azure Storage Emulator. And if you want to take a look into what happens within the storage when you execute your durable functions, you can also install the Storage Explorer. Now, yeah, let's take a look how this looks like in real life. So let's close that one. Let's start up another VS Code. Now we again create a little functions project within the directory. We go for TypeScript, and now we have to create 3 functions. First of all, we have to create a starter. So durable functions HTTP start. We go for anonymous. Next, we have the durable functions orchestrator, which does the orchestration. And last but not least, we have the activity, which is called hello, that is created now. So let's take a look how the project looks like. So first of all, let's install the npm durable functions. Functions. Just to avoid typos, it's S. Will be a good idea. Okay. So how does the structure of the project now look like? So we have the HTTP starter. Again, we have a function.json, which tells the runtime how do we address it. So again, we have this HTTP trigger that we already know. Here we now see that we can also tune in something like a routine. So we have orchestrators and the function name in order to guide the right execution. And we have some output here, and we have some additional binding, which is an input binding that tells the function runtime, hey, dear function runtime, this is an orchestration client. This orchestration client is allowed to call an orchestrator. If this binding wouldn't be there, the function runtime wouldn't know how to hook up things and wouldn't know that it's allowed to, that this function calls an orchestrator. The code is quite easy. So what happens here, I will not go into details because it's anyway, I think a bit too fast then, is it creates a new durable function orchestrator, kicks off the orchestration, and hands over the information that comes in via the HTTP request. Next, we have the orchestrator that does the orchestration. Again, here we have within the binding the information, what type of function is this? And this is an orchestration trigger. So this triggers activities. Azure Function Runtime this way knows what to do. And the code is really easy. So what we have here is an orchestrator, which makes use of the JavaScript concept of a generator function in order to deal with the sequence execution and the possible parallel execution that comes along with that concept. And here, as we can see, we yield, so we execute some activity calls one after the other. And we call the activities really by name, which is hard-coded here, which is not something that you would do in a productive environment. But this is the way how you address the activity. And this is the parameter that you hand in. And as you can see here, we have some nice sequence. We call the first activity, hand in Tokyo. We call the second activity, we hand in Seattle, and the last one, London. And last but not least, we have the activity function. Again, function.json tells the function runtime, hey, I'm an activity. I can be called by an orchestrator. And well, this activity is not really trivial. It returns a hello combined with the information that is handed into the function. So now we have to do a bit more in order to get things running. We have to add types here in order to make it running. And we have to tell the durable function, where do you find your storage? So we have here the Azure Web Job Storage, which tells the function runtime where to store the state. And we do not have a connection to the cloud at the moment. So what we do is we tell it, hey, use a local development storage. That's something that I spun up. And which is then used by the runtime implicitly. So what you see here is, first of all, the cool terminal app of Windows, and you can do a lot of stuff with it, which does not boost your productivity, but looks quite cool. And we have here the storage emulator, which exposes some endpoints, like a blob endpoint, a queue endpoint, and a table endpoint. And the table endpoint is then used in order to store your state. And that is what we use now. We now finish the installation. So we hook up all dependencies, and we can now start the whole thing, which based on the build scripts does the TypeScript thingy. And what you see now here is it again reads the host configuration. Now it makes use of the extension bundle in order to hook up the right dependencies. This is a concept that, as the name says, enables you to extend Azure Functions if the bindings or something like that is not enough in your case. And it looks up all the functions. It finds 3, which is okay. Starts up all the runtime and so on and so forth, and exposes this nice little endpoint that we can now call in order to kick off the function. And that is what we want to do. So let's say orchestrator, we have durable functions orchestrator, yeah. So what we will do now is we call the HTTP trigger function. This trigger function triggers the orchestrator. This calls all the 3 activities. And at the end of the day, we should get back an array of the 3 calls, or the result. So let's execute that. And what happens now is the execution is asynchronous. So we do not get the result directly, but we get back several URIs in order to get the status of the query, or also to rewind the execution or terminate the execution. That's all possible. Now let's take a look if we were successful and make a call to the endpoint. And here we go. We have a durable function orchestrator that was executed. And we have the output that we expected. So we have executed all 3 activities, one after the other, and everything is fine. Now, let's take a look what happened behind the curtains. For that, I have opened my, my Storage Explorer, and I linked that to my local storage. And now we have 2 functions here, two tables here. One describes kind of the basic information, what happened with the function. So we have some runtime status, we have some output, we have some infrastructural information, and we have the name of the function. So we can at one glimpse see, was the execution okay, what was called, what was the output. And we in addition have the history. So all the steps that have been executed when we invoked the function. And what you see here is kind of what you saw on the slides. So what we did is we started the execution, we kicked off the function, an instance was created, and then the orchestrator started. It scheduled a task, which was hello. Then the orchestrator completed, and the task did its job. The task completed, the orchestrator woke up again, checked what do I have to do next. I have to invoke the next activity, calls it again. We also have the output here, what happens when the execution is finished. And at the end of the day, the orchestrator starts one last time, checks if everything is completed, hands back the result, and everything is done. So all this is happening behind the scenes, so you do not have to care about it. If you have a sequence of executions, if you have a parallel execution, so kind of a fan out and fan in scenario, if you have some human interactions in between, that's also possible to handle that way. So that's kind of a first glance into the durable functions. Let's clean up things again. So what I did now, I just cleaned up the storage because I want to show you some more things. So I will now not switch into full screen mode because anyway, we'll jump back to the code in a second. So as I said before, durable functions also help you with a lot of other things. Not only with modeling workflows on a purely code-based way, you also have a non-code-based way via logic apps. you do it purely code-based. And now when you think about real-life scenarios, you might call some backend system from your functions. So maybe an SAP system, which is definitely not cloud native. So maybe the system is not available all the time. So maybe you get some errors due to what reason whatsoever, and you want to do a retry of the call. So you want to kick off the activity 1, you want to do, it fails, but you do not want to let everything fail. You want to make a retry. Now the question is, do you have to implement that manually? Or do you have the option to use something that the framework gives you? And this is something that I would like to show you, because this is really quite some powerful stuff that you have at hand with the framework. So what I have here now is a little bit of a different scenario. As you're now kind of functions and durable functions experts, we have here the trigger function, which is an HTTP starter function. We have some orchestrator, and well, this orchestrator does two things. It calls an activity called purchase order customer dunning data activity, which does some business stuff. So calls an SAP system in order to get some customer dunning data, and based on the outcome, it will call a second back-end system. So to retrieve more data. The activities are not really complex. So what you do here is you fetch some additional data from the downstream system. So from the SAP system, making use of the so-called SAP Cloud SDK, which gives you some nicer interaction with the system. But that's basically just calling a backend system, and this backend system might fail, or you might want to have retries. So how can you do that with durable functions? So in the session, in the example before, we directly call an activity. What we do now is we call an activity with retry. So we hand over the name of the activity. We again hand over the information that we want to put in. In addition, we have one additional parameter, which are the retry options. So here we hand in the options and tell the Azure Function Framework, hey, call this activity, and if something goes wrong, please do a retry. And if you do a retry, please use these options in order to do the retry, like when to trigger the first retry, after which time do you want to trigger the retry? How often do I want to trigger the retry? And so on and so forth. So there are quite some options there that you can use. And what we'll do now, for the sake of the demo, we will do a little trick. So we will trigger this function with wrong data in order to see the retry coming into action. And then when the orchestrator is woken up a second time, which we can kind of determine by the replay in the context, we will adopt the wrong input data to a right input data, and you will see that then everything goes the right direction. So what we will do now is we will now start this little thingy, which will do the build process and so on and so forth. Now let's put that one. Okay, I want to put that one here. So it's up and running. The function is up, so let's put that one here. And that's not so good. So what I have now is I will now call by intention my little durable function with the wrong data, and within the function do this little trick and exchange the data and do the second call with the right data. So let's just do that. So it's sending the request, and let's see what happened. And as you might guess, red color is not good. So something went definitely wrong. And then it seems to work again. So let's take a look at the status. No, I don't want that. I want that. So let's see if something, oh, okay. So the runtime status was completed. I have some input, which was wrong. And I have an output. Now let's see what happened behind the curtains again, because this is really, I think, super cool how the runtime supports you here. So let's take a look again. What happened? So we started the execution, everything's fine, a task was scheduled, and this task failed. Okay, not good. This was the red stuff within the console. So the orchestrator started again and it created a timer, because we said do a retry and we gave in some information when we should do the retry. So orchestrator started, the timer was created, the timer fired after the specified time, and the orchestrator started again and rescheduled the first task. And now the task completed and returned some data, and the second activity was executed. So with a minimal amount of code, you could easily implement retry logic within your functions, which really helps you. As we have already spent quite some time, I want to show you one last thing, one last thing that you could do, or that you might ask. We might have another situation where we want to implement a race condition. So we say we call the function and we call again a downstream system, and if the call doesn't return after 10 seconds, we want to abort the execution, no matter if this call was erroneous or not. As we saw just a moment ago, we can use timers within durable functions. So that was implicitly triggered within the function framework. So the question is now, can we do that explicitly? And yeah, you guess it, you can. So what you can do now is you can model a racing condition by simply calling an activity with a retry and not firing the call of the activity, but just putting it on a stack of tasks that the function framework has to execute. And then also create a timer via the durable functions context with some deadline. And this combination kind of gives you the racing condition. And then you can tell your durable function context or the runtime, hey, I have 2 tasks, please execute them. And as soon as one returns, go on. And now we have a race between a timeout task and the Dunning level task. And this is kind of an explicit usage of the timer. So from a perspective of the storage explorer, this kind of looks the same as we saw just a moment ago. But you can explicitly do that in order to make your life easier. Okay. So let's go back to the slides. So wrapping up what you heard within the last, well, 45 minutes or something like that. Hopefully it didn't take me too long. Functions, the offering that Microsoft has here are really cool. You have a very, very, very low entry barrier if you want to do a local development. So you do not have to sign up to Azure in order to work with Azure Functions. You can do all the stuff locally, play around, make your hands dirty, and then push that to the cloud. You can also do hybrid development. So as you have seen, I've mostly used HTTP triggers. If you want to use something like a trigger from Event Hub or something like that, you can do your Event Hub thingy within Azure, and you can hook that up to the function locally. That works perfectly. And there is one thing that, from my perspective, makes Azure Functions outstanding, and that's the extension via durable functions, which gives you a lot of stuff that you usually have to wrap your head around in order to solve them. And that's done here for free via the framework. I showed you quite some stuff, and I showed you a lot of stuff concerning the time that we had, but there is even more. So the durable functions allow you even more, something like durable entities. So up to now, we had some state implicitly handled by the durable function framework. What about having some state that is globally handled by you yourself? And this is what durable entities are about. Yeah, and last but not least, those little guys just wait for you to try them out. So yeah, thanks for your attention. Thanks for having me, for staying here. Also, the weather outside is super sunny, super nice. So thanks a lot. And yeah, looking forward to your questions.